Hello everyone, my name is Aryan and today I would like to present Proxima, a context-aware proximity-based real-time networking system. So Proxima helps people attending the same physical event such as hackathon, conferences, meetups or tech summits to discover and connect with like-minded individuals nearby in real time. So instead of relying on manual searches or exchanging of social media handles, Proxima intelligently combines the live location, the semantic profile matching, and the real-time communication to recommend the most relevant people around you. Traditional networking platforms are mainly designed for online networking. While they allow the users to search profiles and send connection requests, they are not optimized for discovering people who are physically present around you at the same event. Imagine attending a hackathon with hundreds of participants. There might be someone just like you, standing a few meters away, who shares your technical interest and looking for teammates, but you would never know they exist. Proxima solves this by combining geospatial discovery, semantic understanding of user intent, and persistent connection channels to recommend the nearby participants who are actually relevant, making in-person networking smarter, faster, and more meaningful. So now let's move on to look at the high-level architecture of Proxima. This diagram shows us the high-level architecture of Proxima. So basically, the flow starts at the mobile application from where the user can send their event, intent, keywords, and description as a payload along with the nearby Bluetooth application users and the GPS coordinates. So this payload hits the Go API gateway from where the API gateway can verify the user using Firebase authentication. And after that, the request can be sent to the core backend service from where initially the user intent is shared to the Go ML service, which uses Python sidecar inference, which uses a sentence transformer under the hood to get the user embedding. And after that, after getting the user embedding, it stores that into the intent table and the supervised Postgres that we have. After that, after the embeddings for the particular user is calculated, the core backend service triggers the worker service that we have. And this trigger is asynchronous in nature, so that the user does not have to wait for the things synchronously and they can be notified later when the entire computation is done. So the discovery worker service that we have, it basically takes the user intent and basically first of all it looks at the Redis caching that we have. And if the computation for the users have been already done, it is a cache hit and it can directly return that computation value to the application that we have. And if the computation has not been already done, then it can take the embeddings for all the users that we have, and then it can compute the similarity score, and then it stores that into the Redis caching, so that if later on, if the same embeddings are hit on, then it's a cache hit. And then and if the score that we have passes a certain threshold that we have, then it passes that to the front end, and and it stores into the collaboration table. And using Redis pops up in it then notifies it then hits the API gateway, and the mobile user is then notified about it. Let's look on to the application user interface that we have. So this is the user interface of the Proxima application that we have. So this is the sign in and the sign up page that we have. So this is the home page. This is the discovery page wherein the user can type in the event, the intent, the keywords, and the description they want. This is the collaboration. This is the history page wherein they have two states, pending and accepted. Accepted are the ones in which both the users have mutually accepted each other, and pending is the one which means that if I have sent the request and the other guy has not accepted it yet. Then this is the profile screen, wherein all my personal information I can modify and update as per my needs. Then over here we can see that Shruti and I am already connected. So I can, after getting connected, I can see all the personal information of Shruti which she wants to show to the other users. And I can also message her and talk to her using WebSocket connections in real time, so that we can connect and talk about whatever mutual thing we wanted to talk about, right? Okay. So now let's see the demo video that we have for this entire application. So basically over here we have phone one and phone two, and both users have logged in right now. So basically after logging in, they go to the discovery page wherein they can fill in all the details and intents that they have, right? So they have filled blockchain, collaboration, and all the intent that they particular want to find a user related to, and they are filling the entire uh, intent right now. So we can see that they have filled the entire intent and everything. Now they have clicked on find matches. So it uses hybrid thing, which is GPS and Bluetooth under the hood. And it takes a little bit of time because the entire thing is asynchronous in nature, as we discussed in the architecture. And after a few seconds, they will get the result will get reflected on the screen. So yeah, we can see in the phone two, the result is getting reflected that they have one matching, and in phone one also. So we can see for Aryan it is Aditya, and for Aditya it is Aryan. So just showing that beforehand they were not friends, so like it is empty, and now we can connect with each other. So Aryan has sent to Aditya, and Aditya accepted the request. Now coming into the accepted screen, now I can see Aditya's information, and Aditya can see my information, and we can chat along for whatever reason we connected. Like we can message, like he's greeting him, and Aditya will also greet him. So, and this is the profile page that we have. We can update our personal information over here, and then we can log out. And this was the basically the demo of the entire platform, Proxima platform that we have. Now let's talk about the tech stack that we have. So basically, the API gateway is made in Go language and uses Gorilla WebSockets for REST API routing, WebSockets upgrades, JWT authentication, request validation, and rate limiting. Then for the backend service, we are also written in Go, which the purpose of which is writing the core business logic, the profile management, the signed URL generation, and matching orchestration. The worker engine is written in Go and also utilizes Redis streams, which does the asynchronous job processing, geospatial matching, semantic search execution. Then the ML service, which is written in Python, Flask, and sentence transformers, the main purpose of which is intent embedding generation. Then for database, we have PostgreSQL, PostGIS, and pgvector, which uses like vector similarity searching, which is ANN, HNSW under the hood, and persistent storage and geospatial queries. Then for caching, we are using Redis. For authentication, we are using Firebase. And for real-time communication, we are using WebSockets. For storage, we are using Superbase storage. And for deployment, um, for basically all the spinning up of the containers, we are using Dockers and Docker Compose. So the system architecture we have already discussed about. And now talking about the engineering decision. So this project took me a very long time to design so that everything is designed perfectly and nothing acts as a bottleneck. So it took me around 6 months to develop this project and to develop everything like what should be used at a particular level, and that should not act as a bottleneck. So all my engineering decisions, the decision that I have and the rationale behind it, I have mentioned everything, like why microservice architecture, why WebSockets over HTTP polling, why Redis CO, why Redis streams, and why a lot of other things that I chose over the other alternatives that I had. Everything is written over here. So if anyone is interested in understanding the architecture that I have, he or she can come and visit my GitHub README file, and they can understand everything, like basically the rationale behind why I was thinking of this particular architecture. But more or less everything I have discussed in the high level design architecture video that part that we had, right? So and yeah, that's this is exactly everything about the Proxima application that we have. And yeah. So just to conclude, Proxima is a real-time proximity-based networking platform that enables the people at the same location to discover smartly, intelligently, and have a more meaningful connection. So yeah, thank you. And if anybody wants to read more about the entire platform, they can visit my GitHub. And inside my GitHub, there is this GitHub repo of Proxima, wherein they can find this README file and they can know more about it.